Hello, in this video we're looking at MEI FP2, the June 2011 paper question 3, which is on matrices. It's a good idea to read the whole question through first. First of all, we're asked to find the value of K for which that matrix does not have an inverse. Then, assuming that K does not take this value, find the inverse of M in terms of K. Then we're asked to consider the case K equals 3 and evaluate the matrix multiplied by that vector, and to state the significance of what we found, noting that that's worth 2 marks, so we probably need to say 2 things. For part 4, we're asked to find a value of t for which that system of equations has solutions, to find the general solution in that case, and to describe the solution geometrically. So lots of things to do there for those 7 marks. Okay, for part 1, having read the question through, we know that in a minute we've got to find the inverse of M. So to check the determinant, it's probably best to use the cofactors method rather than Sarris's method, as we're going to need the cofactors anyway. So our first cofactor, ignoring 1 and that row and finding the determinant of this matrix here, that's 16 minus 12. For A2, we ignore that bit and find the matrix of what's left, remembering to put a minus sign in first. So that's minus 4 minus 2k, which is 4 plus 2k. And then for A3, we cross that out and get minus 6 minus 4k. Then the determinant of M is that first cofactor, which was equal to 4, times the first entry 1, plus 5 times 4 plus 2k, plus 3 times minus 6 minus 4k. That's 4 plus 20 plus 10k minus 18 minus 12k, which is minus 2k plus 6. If we're interested in the matrix not having an inverse, we're interested in the case when that equals 0. So the determinant of M equals 0 implies that 2k must be equal to 6, and therefore k is equal to 3. To find the inverse in the case k is not equal to 3, we need the other cofactors. So B1, that's minus 20 minus 18, which is minus 2. B2 is 4 minus 3k, and B3 is minus 6 minus 5k, or 5k minus 6. And finally, dealing with the final column, C1 is 10 minus 12, which is minus 2. C2 is minus 2 plus 3, which is minus 5, and C3, 4 plus 5, which is 9. We know that the determinant of M is 6 minus 2k. So the inverse, 1 over the determinant, and we need to take each of these elements and transpose it, so we get going across the top 4 4 plus 2k, minus 6 minus 4k, and then the next column as a row, minus 2, 4 minus 3k, 5k minus 6, and then minus 2, minus 5, and 9. For part 2, in the case k equals 3, so carefully copying our matrix, 1, 5, 3, minus 1, 4, 2, and putting 3 in for k, 6, 4, and multiplying by minus 3, 3, 1. We get minus 3 and minus 3 is minus 6, plus 3 is minus 3. Minus 15 plus 20 is 5. Sorry, minus 15 plus 12 is minus 3, plus 6 is 3. And then minus 9 plus 6 is minus 3, plus 4 is 1. So I get the same vector. So the significance of this is that minus 3, 3, 1 is an eigenvector. Corresponding to eigenvalue 1. And finally for part 4, you'll notice that k is 3, and so the matrix has no inverse. So we can't use a matrix method, so we have to use an eliminating method. So here we go. 2 times the first equation plus the third equation gives us 5 lots of x, no y's, 10 lots of z, equaling 2t. And 4 times the first equation plus the second equation will also eliminate y and give us 9x plus 18z equals 40 plus 1. I'll call those equations 4 and 5. If I multiply equation 4 by 9, I get 45x plus 90z equals 18t. And multiply equation 5 by 5, I again get 45x, and this time plus 90z equals 20t plus 5. So these equations have solutions when those are consistent. In other words, when 18t is equal to 20t plus 5. In other words, 2t is minus 5, so t is minus 5 over 2. What that means is that 5x plus 10z must be equal to minus 5, which means that x plus 2z is minus 1. So if I say that x is equal to the parameter lambda, then z is equal to minus 1 minus lambda all over 2. If I substitute that into the first equation, I get lambda minus y minus 3 minus 3 lambda over 2 is equal to minus 5 over 2, giving me that y is equal to lambda minus 3 over 2 I'm going to make sure my minuses are clear there, minus 3 lambda over 2 plus 5 over 2, so that y is equal to 1 minus lambda over 2. So I don't have a unique solution, I've got a range of solutions. I can see clearly that my 3 planes are not coincident or parallel, and therefore they must form a sheaf. So the 3 planes form a sheaf. Okay, let's see how the mark scheme works for this question. For part 1, there is a method mark for at least 4 cofactors, including at least 1 with k in it. There's then an accuracy mark for all 6 signed and correct. For the first part, when we're finding the determinant, there's a method mark and an accuracy mark for getting that determinant by any method. It might be by the cofactors method, perfectly okay to do it by Samus's method, but you've then got to find the cofactors again later. And an accuracy mark for finding that k must be 3. Going back to the inverse of our matrix, there's a method mark for transposing and dividing by the determinant, and that's dependent on the previous method marks, and an accuracy mark for doing all of that correctly and ending up with a correct inverse. For part 2, there's a method mark for setting k equal to 3 and multiplying, and an accuracy mark for getting minus 331. And there's then a mark for commenting that it's an eigenvector, and another mark saying that that corresponds to the eigenvalue 1. And those 2 marks are dependent on the previous M1A1. It's also acceptable to say that minus 331 is an invariant point. For part 4, there is a method mark for eliminating one variable in 2 different ways to get 2 equations. There's an accuracy mark for doing that correctly, and there's then a method mark and an accuracy mark for any valid continued working to find a value for t. There's then a method mark for getting a general solution in terms of lambda, and a mark for correctly describing that geometrically as forming a sheaf. If you want to find videos on other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.